Beautiful. Good. Good. All right. Okay. So for the second line here, right? Same idea for the slope. We have change in y. So you can see change in y. So we have 6 minus 2. Okay. We're dividing it by corresponding change in x from second to first point. Same thing with the x coordinates. So we have over 2 minus 6. 2 minus 1, excuse me. So we have 6 minus 2, all divided by 2 minus 1. We get 4 over 1, which is 4. Okay, that's good. Now, let me just say this also. Well, first let me ask, are there any questions about this calculation? Okay, well, notice that both slopes are positive, right? Both of the lines here have positive slope, and look at what the lines are doing. If we were to move to the right along the horizontal axis, the x-axis that is, you can imagine walking along it towards increasing numbers. What are the lines doing? They're rising. They're going up and to the right. They're rising. If you think of the top here as north, over here this is east, they're both going northeast. That's no coincidence. Lines with a positive slope as you move to the right along the x-axis, the horizontal axis, lines with a positive slope are going to move up to the right, as you can see. They're going to move in the direction of northeast. In other words, they're going to climb up, climbing. Okay. So we know that, so we have that. But what else do we know? Well, notice the blue line has a slope that is, I probably should not have used blue over here. I hope that's not causing confusion because this line is green. But the blue line has a bigger slope, right? The blue line has slope 4. This line has slope 2. The blue line is steeper. It's more vertical, right? Well, that's no accident either. The bigger the slope of a line is, the more positive it is, the more vertical it's going to be, the more steeper. Okay. All right, so that's what's happening here. So let's do another example similar to this. Okay. For this one, we have, again, a green and a blue line. They're passing through, again, the point 1, 2. The blue line's going through 4, negative 1. The green line's going through 4, negative 4. All right, let me get the pen out. Okay, so for the green line now, right, we have these 2 points, 1, 2, and 4, negative 4. So let's calculate slope. Again, change in y, right, as you can see. So negative 4 minus 2 divided by the corresponding change in x, which is 4 over 4 minus 1. Negative 4 minus 2 over 4 minus 1. And if you do that calculation, as you can see here, if you do that calculation, right, we have negative 4 minus 2, which is negative 6. 4 minus 1 is 3. Negative 6 over 3 is negative 2. That's for the green line. All right, well, what about the blue line? Well, let's take a look. For the blue line, that's passing through points 1, 2, 4, negative 1. So let's do the calculation. For the slope, negative 1 minus 2. Okay, negative 1 minus 2. We must divide, right? we must divide by the corresponding change in x. So we have 4. What am I doing? Let me fix that. There we go. Just want to fix that. Stay on the slide. So we have -1 minus 2 on top divided by 4 minus 1. Again, the corresponding change in x. Okay? So for the y values, we go from the second to the first point. Same thing for the x, second to first point. We have -1 minus 2 over 4 minus 1. That's -3 over 3, which is -1. So this line also has a negative slope. So both of the lines have a negative slope. Okay, that's good. So what do we notice? Well, notice that if we move to the right along the x-axis, the horizontal axis that is, towards bigger numbers, to the right, these lines are falling, okay? In other words, again, if you think of this as north, this is south, this is east, they're going southeast. They're pointing down to the right, down to the right. Well, that's what lines with negative slope do. They're falling as you walk to the right along the horizontal axis. The lines are falling. Okay? Not only that, notice the green line has a slope, -2. It's more negative than the blue line, whose slope is -1. The green line, right? It's steeper. That's no accident either. The more negative the slope of a line is, the steeper the line is. So the more positive, that is, the slope of a line is, as in the previous slide, the steeper it is, the more positive it is. Here, the more negative it is, the steeper the line is, if it's negative. So that's what's happening here. So just to summarize the stuff we noticed, that's on this slide, right? A line, as we can see, with a positive slope, that's going to rise as your x, your independent variable increases as you move to the right. Okay? Positive slope, the line's rising. The larger the slope is, the more vertical the line is. A line, though, with a negative slope, that's going to fall as your x increases, as you move to the right. That's what I was trying to say here. You're moving to the right. These lines with negative slope, they're falling. Okay? And the more negative the slope is, the more vertical, the steeper the line is as well. All right, that's good. Any questions on that? Okay, let's keep going. So remember, we said that a line is the graph of an equation. Now, if the line is not vertical, we use the slope to get an equation of that line. And really, we need a point on the line as well. Now, one way to write, I did it here also. Oh, it shouldn't be formula, it should be form. I'm sorry about that. I thought I deleted that. There we go. So one way to write an equation of a line that's not vertical, assuming we know a point on the line and the slope, we can write an equation of the line in point-slope form. In other words, if we have a line, okay, and let's say we know that line has slope m, and let's say we also know that the line passes through this point, AB, then the point-slope form of an equation of the line, okay, That's going to be this, y minus b equals m times x minus a. Y minus b equals m times x minus a. That's what's going to happen here. Okay, awesome. And again, that's just one way of writing an equation of the line. And really, this point AB could be any point on the line. So for instance, if we go to this line here, the line that passes through the points 1, 2, and 2, 4, right? That was one of the lines here. That was the green line here. And we saw that that line has slope 2. We can get an equation of that line. Namely, the point slope form of an equation of that line using the first point, 1, 2, right? Using that point would be this, y minus 2, right? Y minus b from the definition. B is the y coordinate. So y minus 2 equals 2. 2 is the slope here, times x minus 1, x minus the x coordinate. So again, using the point 1, 2, right? And the slope is 2. That's not, that's what we calculated. Y minus the y coordinate 2 equals the slope 2 times x minus 1. 1 is the x coordinate of the point. If we use the second point instead, 2, 4,